So on today, we'll round up. We may not finish the topic today, but we will do as much as we can. And some of you that sent me email for the makeup, I received your emails. I'm still probably by tomorrow night, I will start responding. I received the email and I'm preparing the questions that I will be sending to you for the makeups. So as soon as I get them ready tomorrow, probably tomorrow night, I'll start responding. So be patient. So we begin today from standard normal distribution. As you can see from the screen, a standard normal distribution simply means a normal distribution that which has a mean of 0 and a standard deviation of 1. And all normally distributed variable can be transformed into a standard normal distribution using this formula here. You can see the formula on the screen. Z equals S minus mean divided by standard deviation, where X represents the data value, Z the standard score, mu mean, and delta standard deviation. So let us apply this. Again, remember, in working this out, the first thing you do is to transform the variable into a standard normally distributed variable using this formula here. After that, next thing you do is to draw your chart and then go from there. Go to the table, get your values, and then find the answer. So look at this question here. It says, I'm going to move this question down a little bit so that we can, let me copy this formula here because that's what we'll be using. Put this formula here. Okay. Now it says here that the monthly utility bill for in a city are normally distributed with a mean of 0, so with a mean of $100 and a standard deviation of $12. And it says a utility bill is randomly selected. A, find the probability that the utility bill is less than $70. B, find the probability that the utility bill is between $90 and $120. C, find the probability that the utility bill is more than $140. So let us start with the first one. Okay. So first of all, let's have this. Part A, before A, let's have our mean and standard deviation. Say that the mean is $100 and the standard deviation is $12. Okay. So using the symbols, I have that the mean, okay, the mean is $100. Okay, equals $100. And the standard deviation, let me make this sense. Let me make this sense. Should be 18 is good enough. Okay. Mean is $100. And then the standard deviation is, what is the symbol right? It's right here. Oh, excuse me, a mistake. I'm going to put it beside this one. The standard deviation is equals $12. So I'm going to unbold it. So now for part A says, I'm going to move it up a little bit. A says, find the probability that the utility bill is less than $70. So that means our X here, X equals 70. So now what we're gonna do is to transform this $70 to a standard normally distributed variable using this formula here. The formula is this: Z equals X minus mean divided by standard deviation, which is equals, I'm gonna make this to be 18, which is equals to, you have X, parenthesis S is 70 minus 100, because I mean is 100, divided by standard deviation of 12. That gives us, I'm gonna write this on paper. C, Z equals X minus mean over standard deviation, which is 70 minus 100 divided by 12. So you can go to our calculator, the Desmos calculator. I'm gonna find it. So I know it's somewhere here. So I'm gonna go to my calculator. I'm gonna have it somewhere here. It's gonna be somewhere there. Okay, so I'm gonna put it here then. Desmos. Okay. Desmos. Okay. Now, let me share Desmos here. So you have X. Remember what we have before is on the paper is 70 minus 100 divided by 2. So we're gonna put it in there. So you have 70 minus 100 divided by 2. 12, I mean to say 12. Negative 2.5. So we go and put it in our answer there as negative 2.5. Negative 2.5. Now it is not, it is no longer 70. It is now, it has been transformed to negative 2.5. And it is no longer an X, it is now a Z. So the probability that the utility bill is less than 70 now becomes the probability that the Z is less than. So we're going to use a less than symbol here. Less than, instead of less than 70 now becomes less than negative 2.50 equals. Now, at this point, this is the point in time you can now draw the chart. So now, the chart goes like this. It's on the left side, negative 2.50 is because it's negative, so it will be on the left side of the chart of the 0 and 0. Then if you put your x-axis and this the bell curve, okay? X-axis and the bell curve. This is your x-axis, and this is your bell curve. Okay. Now you can put the center line. This is where the 0 should be, which is the mean of 0. So I'm going to move this back a little bit. Okay. And they put a line that represents the negative 2.50 right here. And they say less than that. So you have to shed this side. Because I say this side is less than that. Left side, so less than negative 2.50. You shed it. Okay. All right, you shed it. So now, so that the probability of z less than 2.50, now this is now the time now you go to the procedure chart to look for the chart that looks exactly like this one and follow the direction from there. Now, let me say one more time. The table you see in your homework in my math lab is a cumulative time. If you know how to use that cumulative table, fine. But I recommend that you use this one we're using in the class, and this one, the chart. This chart goes with the one you're using this chart in the class. This chart that I'm going to show you now doesn't go with the one you have in your homework in my math lab. So, but if you know how to use that, fine. But I recommend this one for the class. Anyway, let's go to the chart, procedure chart. You can see it right here. And you can also see that this one here is one that looks like, see this, the second one is one that looks like exactly what we drew. And the instruction there is to look up the z value to get the area, subtract the area, so long as it is at the tail. This is tail. In our own case, it is at the left tail. Look at our own case, it is at the left tail. See, that's why it's shaded. So the procedure chart says that you look at the z value to get the area at subtract the area from 0.5. So this is z value, and the area we are looking for is negative 2.5. Okay. Why did he say subtract the area from 0.5? Because half of this is 0.5. And this other half is 0.5. So if you're looking for only this small area, you're going to subtract it from 0.5. So the 0.5, and since all the data set numbers in the table is 4 digits, so you make it 0.500 minus, and then look for negative 2.50. Now, if you're using this table, you don't have to worry about the negative. Just look for 2.5, because by symmetry, it's the same as negative 2.5. And besides, negative sign is just to tell you that it's on the left side, that's all. So look at this table. We have 2.5. We can see the z right here. Look at 2.5 here under 0. Which it is 0.4 0.4938. Okay, so give me 1 minute. Let me write this down. Okay. 0.4938. How do I know it's under 0? Because if you go up, you can see that it comes under 0. 0.4928. That's 38. 4938. So that's our area for 2.5, negative 2.50. So you got 0.4938, which we can get from the calculator as our decimals will tell us what it is. So we got 0.5, 5000 minus 0.4938. Give me 0.0062. So we go to our answer and put it here. 0.0062. So 2.0062. So that the probability that the utility bill is less than $70 is 0.0062, or just 6.62%. Does anybody have question on what I just did? Any question? Yeah, good. Now let's look at part B. Part B says, find the probability that the utility bill is between $90 and $120. Okay. Now, again, we have our mean and the standard deviation staying the same, mean of $200. Okay. Part B, I will have the mean of $100 and the standard deviation of $12. Okay. So, and they told us that to find the probability that your utility bill is between $90 and $70. So that means we have 2x. The first one, unlike the one we just did, we have only one x. This one will have 2x. That the first one is 90, and the second one is 120. So they do two. So that means that we're gonna transform two of them. Okay. So we have our x1, let me go from here. We have x1 equals 90 and x2 equals 120. So that we're going to transform both of them. To transform x1, we call it z1 equal. So I'm gonna make some adjustments here. x1, x2, and then z1. So to transform x1, I'm gonna use z1. Okay. Z1, just making sure you're seeing all this. Yep, you're seeing it. Z1 equals x1, which is a 90 minus mean of 100 divided by standard deviation of 12. So sorry, mean of 90 minus 100 divided by standard deviation of 12. I'm going to write this down. Z1 equals 90 minus 100 divided by 12. Okay. So we got in the calculator we have 90 minus 100 divided by 12 is negative 0.83. Okay. Negative 0.83. Negative 0.83. Now let us transform x2 using z2. Okay. Z2 equals, I'm going to adjust this. Z2 equals, our x2 is 129. And make sure. Oh, 120, not 129, 120. Sorry. 120 $100 minus $100 divided by $12. That gives us, I can just go to the calculator. Oh. So I put this. So so you have our Z1 is 90 minus 100 divided by 12. This is negative 0.83. And Z2 now is 120 minus 100 divided by 12. That gives us 120 divided by 12. Sorry, 120 minus 100 divided by 12 equals I just go down and put 120 minus 100 divided by 12. It gives us 1.67 rounded. I'm going to write it here. Z2 120 minus 100 by 12 give us 1.67. Okay. So round, so let's go and put 1.67 there. 1.67. Okay. Now with this, we are now have the two. It is no x1. It is no longer 90. It's now negative 0.83. And it is also no longer 120, but it's now 1.67. And S1 transformed to Z1, S2 transformed to Z2. So now, the question was, find the probability that the utility bill is between 90 and 120. That will become the probability, okay, that the bill is between 90 and 120. That becomes between negative 0.83. And this is how we write it. Normally write it. We're gonna put it in this form. Okay, less than Z, less than 1.67. This is how we write it. We become, to answer this, you need to draw the chart. Here I have negative 0.83, have 1.67. So you can now put the this chart in. Okay, can put it in now. Okay, we'll start with the x-axis part of it. Okay, then this part. Okay, all right. So we can just move this in a little bit. So we can now put all the center line, which is this right here. Okay. Now a line that represents negative 0.83 and a line that represents 1.67. Then between these two, you share between the two. So I can use this to share between the two. I can use this. Once you finish shedding, you can now go to the procedure chart. Look for the chart that looks exactly like this one. Okay. The procedure chart is right here. I think I just place it. Let me find it where it is. The procedure chart is right here. So I'm going to share it now with you. Okay. You can see that this is the one that looks like what I have. Now, don't forget that this is what I have here. Okay. This is what I have here. And this chart here is one that looks exactly like that one. This chart in number 4. And what did it say? Look at the z-value to get the areas and the areas. So having found that, we go to this. Let's find the value, z-value for negative 0.83. So that for negative 0.83, we look at the table. The table we have is right here. Okay. So that's this table. We have negative 0.83 is 0.8. You're not looking for negative 0.83. Remember, I say negative sign is just to tell you that it's on the left side. Don't worry about the negative sign. Just look at 0.8. That's Z 0.8. You go under 3. See? 0.8. Go under 3. That's it right there. 0.8 is write this down. Probability of negative 0.83 less than Z less than 1.67 is for 0.83. The Z value is 0.2967, and for this one, which is let me put this first, 0.2967 plus, now for 1.67, now you go to the table again. 1.6 under 7. Look for 1.6. It's 1.6 right here. See? Make sure. Yep, 1.6 here. Go under 7. I see 7 right there. 1.6 right here. 0.4525. 0.4525. So we can go to our this word and put 0.4525. Then this is what we're gonna put in the calculator. So let's put it on the calculator. Okay. So you have 0.2967 plus 0.4525. Is 0.7492. So you can go and put it in 0.7492. So that the probability that the utility bill will be between $90 and $120 is 0.7492. Any question on this? Any question?
No.
Okay, good. Excellent. Now let's look at part C. Part C says, find the probability that the utility bill is more than $140. So again, we have our mean and the standard deviation. Mean and standard deviation should be, that is for part C. Okay. To be this. Okay, it's the same mean and standard deviation. So the only thing that changes is the X value. So B, sorry, C part of it. Mean and standard deviation. Now, in this case, our X is equals, it says more than $140. So X is 140. 140. So that we can now transform this. Let me move this down so we can have enough room for this. I can go to the next page. Yep. So we have, let's do the transformation. Of course, remember the formula. So we have Z equals S, which is 140 minus mean of 100 divided by standard deviation of 12. Okay. So you have 140 minus, okay, minus 100 divided by standard deviation. Let me write this down. Z equals 140 minus 100 divided by 12. Okay. We can now go to our calculator and put this in. We have that 140 minus 100 divided by 12 give us 3.33. 3.33. Let's go and put it in there. Give us 3.33. So it is no longer 140. It is now 3.33, and it's no longer an X. It's now a Z, which means that the probability that the bill is more than 140 becomes the probability that the utility bill Z is more than, right? It says more than, I believe. Let me see. Yeah, more than. So more than, you gotta put the greater than symbol this time. Is it greater than? Okay. Is greater than, let's see, 3.33, which will be equal to you create you draw the chart for it. And draw the chart. That's 0. Let me check something. Just 1 minute. 1 minute. Yeah. So you have this 0 and 3.33. Okay. Get down a little bit. So you may put your this one here and put your bell curve. Okay. Let's see. Okay, now we can have this. Then put the line that represents 3.33, which is right here. And they say more than that. So we gotta show you want to share to show more than that. Okay. So more than 3.3, that means this is a part of it. So share it. Say this is more than 3.33. Okay. Now, then you can now go and look for the procedure chart, one that looks like this one. So let's go and look for it. I think I have to look for it again. Let's see. The procedure chart is right here. I'm going to share it with you. This one is on the tail. You can see on the tail right here. So it says, look at the Z value to get the area, subtract the area from 0.5. So he's going to be looking for the area and subtract it from 0.5. So let's, what area are we looking for now? This time around is 3.33. So you say subtract from 0.5. So I'm going to put 0.5 minus, then let's get area for 3.33. Okay, 3.3 under 3. So the 3.3 is right here. You go under 3. See, under 3 is under 3. And it is 3.33. So that gives us 0.4996. Okay. Can I go and put it on that place? 0.4996. So 0.5 minus that. Get 0.5 minus 0.4996. So you give me the answer in a scientific format. But remember, negative 4, 10 to the power negative 4 means 4 zeros before, you gotta put 4 zeros before 4, which is 0.0004. So before this 4, I'm talking about this 4 here. This negative 4 means 4 zeros. 1 0, that's my point, then 3 zeros before this number here. So you got to be 0.0004. That is the probability that it will be more than $140. Very slim probability. Will be that amount. Okay. Any question on this, guys? So no question. Good. So at this point, we are ready to take a look at the next concept. This one here, you can try this as a practice for you. Let's look at the concept of finding data values using specific probabilities. In this case, we use this formula here. X equals Z times standard deviation plus the mean, where X represents the data value, delta represents the standard deviation, and mu represents the mean. So this is the formula we use in this case here. We use this formula to get it, and then we go from there. So let me copy the formula, and we'll solve some examples here. It says the first example we solve is here already. It says to qualify for a police academy, candidates must score in the top 10% on a general ability test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify and assume that the test scores are normally distributed. So first of all, this is the formula here. So let's get our values out. They say that mean, of course, they say mean is equal to 200. And that the standard deviation is equal to 20. So now, let us find out, before you can do anything, we need to find our Z. Let's find what Z is here. Okay. Now, to find Z, we need to make our chart. Okay. This says top 10%. That means your score will be greater than the 90% of people who take the test. So that means the score that is in the top 10% is the score such that 90% of the scores will be below it. So it means this is how the chart will look like. So you have 0. Your score will be here in the top 10% of the chart. So I'm gonna put it in this form. First of all, let me put the x-axis. Okay, then put the bell curve. Then put the center line. Then put this a little bit, and then put it back. Center line. Okay, center line, which represent the mean. Okay, and then we're gonna have this one here, top 10%. It's gonna be this is where your score gonna be, to be in the top 10%. Okay. Now that's what represents top 10%. As you can see, it is at the tail, right tail. I'll call it the top 10%. 10%. So it's at the tail of the bear curve. See, it's the top 10% right here. So that means 90% will be below it. 90% will be below this score. Okay. 90% to be below it. So the whole of unshaded part represent 90%. You're in the top 10%. So by what procedure chart told us is at the top 10. To get the area, you subtract from 0.5. So top 10 is 0.5, which is because half of this is 0.5 and this half is 0.5. So 0.5 minus 10%, which is 0.1. That'll give us 0.4. Now you go to the table of normal distribution and look this time around, you look inside the table for 0.4000. And when we do that, what do we find? 0.40000. So one that is closest here is, we have two numbers there, 0.3999 and 0.4015. Let's check both of them. I'm going to write this down. I have 0.3999 and then 0.4015. So let's check this one first. Which of them is closest to 0.400? So let's ignore the decimal point and call it 39997 and call our number here to be ignore the decimal point, call it 4000. So let's check it on the calculator, see how far away it is. So we got 4,000 minus 3,996, I think. Hold on, let me make sure I wrote it down properly. Yeah, it's 3,997. Okay. So 4,000, okay, minus 3,997 it is 3 points away, which means that 3,997 is from here is only 3 points away from 4,000. Now let's check this one, 4015. So let's check that one, 4015. Okay. So you got 4015 minus 4,000. This one is 15 points away. So you can see that 0.3997 is closest to 0.4000. So you follow it to the left, 1.2, then you follow it up. It's under 8. So it's 1.28. So we go and put it right there for as our Z. 1.28. So once you get that one, once you get your Z, you're almost done. Because they were asking us what is the lowest score. So find the lowest possible score to qualify. So I'm gonna put it this way. The lowest possible score to qualify is, okay, I'm gonna move this down. The lowest possible score to qualify is I'm gonna use this formula here. X was Z times standard deviation plus mean. And our Z is 1.28. Standard deviation is 20 and mean is 200. Just plug it into this formula and we get our answer right away. So X score, okay? Score, lowest score to qualify. So I call it lowest score presented by X equals our and make it 18 equals Z, which is 1.28. Okay. Yep, 1.28 times standard deviation is 20. Then plus mean of 200. Excuse me. So you can now, I'm going to write this down and we evaluate it. So we got X equals 1.28 times 20 plus 200. So that let's go to the calculator and get it right there. So we got 1.28 times 20 plus 200 is 225.6. 225.6. That's the lowest possible score to qualify. So I'm going to go and put it in there so that we have 225.6. Any question about this? Any question, guys? So no question. Good. Now, since there's no question, let's proceed to the next one. It says here, for a medical study, yeah, medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people to participate in the study. So in that case, mean is 120 and then standard deviation is 8. So let us find the Z first, like we did in the other one. So I'm gonna move this down. To find the Z, we need to make our chart. It says middle 60%. Okay. Let's see. I mean, you're gonna have and they're looking for upper and lower readings. So is this X1 to be lower reading? And mean is 0, and X2 becomes the upper reading. Okay. So that means we're gonna find lower reading X1, lower X1, lower reading X1, okay? And then we need to find the upper reading X2, excuse me, X2. So before you can do that, we need to find Z first. So and to find Z, we need this chart. To make the chart, we have the X-axis, so we have, I'm gonna make some adjustments here so that we have okay, and X2. So since there's two Z-axes, we're gonna find the first one got be Z1. So we're gonna find Z1 first of all. Z1, to draw the chart, of course. Okay, put the shape inside, put the bell curve. Okay. 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 I don't like it. I don't like this curve. I didn't draw it well. Williams, let me bring Williams in. So let me yeah. I think it's in. So let me draw it. I don't like the way you have to look at least as close as possible to the, something that is metric. So let's draw it again. I'm gonna put this right here. Okay. All right. That's better. That's better. I need to. So I'm gonna bring this in and then bring this one in a little bit. Make the center line. Come back to the center. Good. I think that's better now. So now we can have our center line added. Okay. Add the center line right here. We are talking about the middle 60. That means from here, X1 and X2. Middle 60, that means it's 30 on both sides. Okay. Okay. So you have 30% here. 30%. Okay, let me see. This is better to put it that way. 30%. Okay, and here, the same 30%, that will make it 60%. Okay, so we're talking about the middle 60, and we're gonna shed it, shed it the middle 60 based on their blood pressure. Okay. Okay. Now, half of it is 0.30, so it's 30. So now we have for Z1 is 0.300 because it's between 0 and X1, between 0 and X1, that's what it is. Which on the table of normal distribution, you go and look for it. I'll take you to the table, look for the number that is closest to 0.30 and ignore the decimal point, well, call it 3,000, okay? So we can go to make it easy to find on the table. So 3,000, okay. I didn't see exactly, but you see this one here is 23 points away from 3,000, but this one is only 5 points away. I showed you how to figure it out, but it's only 5 points. 3,000 minus this will give you 5 points. This minus 3,000 will give you 23 points. So this one is 23 points away. This is only 5 points away. So this is the one we choose, that one that is closest. Follow it to the left, 0.8. Follow it up, 4.84. 0.84, 0.84, 0.884. Okay, 0.84. So by symmetry, okay, by symmetry, since they're the same, 0.3 on both sides. So by symmetry, Z2 will also be 0.84. Okay, by symmetry. Z2, I call it Z2. Okay, since I'm going to look upper, so Z2 will also be 0.84. But remember, Z1 is on the left side, so you're gonna be negative 0.84, and Z2 will be on the right side, you're gonna be positive 0.84. So now with that, we can now calculate the lower and upper. Okay. Remember the formula is let me get right here. X equals Z as the formula right there. Okay, so that's what we're gonna apply here to get the answer we are looking for. So you have this one as well. So we have S1 equals Z1 times standard deviation plus mean, and Z1 is negative 0.84. Negative 0.84 times standard deviation of 8 plus mean of 120. Okay. Now I'm gonna copy this since I'm gonna use it for the other one since they're symmetrical, but only that I'm not gonna use the negative sign for the Z. Anyway, let's put this on the calculator. I'm gonna put this on the calculator now. So we have okay. So we're gonna have this. I put negative 0.84 times 8 plus 120. So we go to that calculator here, and we have negative 0.84 times 8 plus 120. Give me 113.38, 113.28 millimeter of mercury. That's how they measure it. Those of you on the medical line knows this. Give me 113.28. Then the upper readings, the same thing, but this time around is no longer, the negative sign will not be there. So I can just go to the calculator and remove the negative sign. That's all. It will fix the thing. Take off this negative sign. Give me 126.72. So I got 126.72. Okay. 126.72. I'll put 1 millimeter of mercury. That's how they write it. Those of you in the medical line, Oh, this is business class, business school. So yeah, I expect so you are, most of you, all of you are in the uh business, business. Those medical line know how to. But you know, as a matter of fact, even if you're in the business, you still check your blood pressure. These days they have portable blood pressure machine that you can even buy in Amazon. You know. Any question on this? Any question, guys? Okay, good. There's no question. So let's look at the last one for today, and we close. So our next class we start from central limit theorem. Now look at it. It says, suppose that the SAT scores are normally distributed with a mean of 950 and the standard deviation of 200. Compute the 95th percentile score. So now our mean is 950 and the standard deviation is 200. Let me make this 118. Okay. So they want us to find 95th percentile score. Before you can find that, we need to find our Z equal. And to find our Z, we will need our chart. Okay. Okay, we need our chart. I'm gonna put this chart right here. And the 95th percentile score is the score. Let me put this way. Is the score such that 95% of all the scores, all the people that take the test, their scores, 95% of their scores will be below the 95th percentile score. So we're talking about the top 5% in this case. Okay. So you have 0 and X. Then you can now put the diagram. Put the X-axis. And you put the bell curve. Just right here. Okay. And you got I'll move this a little bit closer. Now you put the center line. And then, move this here. And put the line that represents the what should have been a Z here. I put it right there. And the top 5%. So we're gonna share it. That's okay. Because like I said, 90 percentile score is a score such that 95% are below 95% of all the scores top 5% are below it. So we have the top 5% right here. Okay. Okay, I think I got it right here. Okay, right here, this is cutoff is top 5%. And 95% of all scores are below that. Okay. 95% of all scores are below that. So now, this is it at the right there. So according to what we have in the procedure table, we subtract from 0.5, 0.5 minus 0.05, which give us 0.5. Write this down. Well, I think I can figure it out in my head. 0.5. Okay, 0.5 minus 0.05 is 0.45. So 0.4500. So we got 0.4500 here. 0.4500. Now ignore the decimal point. Look at it at 4,500. So to make it easy for you to find in the chart. So you go to the chart, 4,500. Find the number that's closest to it. 4,500. Have 4495 and 4505. And both of them are equally close. If I say 4500, okay, I'm going to write it down. If I say 4500 minus this one here. What is it? Right here. 4495. So if you do it on the calculator, you can see that 4500, which is what we have, minus 4495 is 5 points away. Now, if you repeat the same thing for the other number that is said to be closest, which is this one, 4505. Okay. So it's how 4505. Let's go to the calculator. 4505. 4505 minus 4500 is 5 points. So both of them are equally close. When you come to this kind of situation, you choose the bigger one, the bigger of the two numbers, which is this one here, and follow it to the left. 1.6. Follow it up 1.65. 1.65. So our Z is 1.65. Okay. 1.65. With this now, you can now estimate the 95th percentile. Okay. Once you have the Z, you can now just plug it into this formula to get it. So the 95th percentile score now becomes the score X equals Z, which we got as 1.65 times standard deviation. I'm gonna make this 18. Standard deviation of 200 plus the mean of 950. And that gives us the 90th percentile score. So let me write this down. 1.65 times 200 plus 950. So let us see. Okay. Let us go to the calculator and get it. 1.65 times 200 plus 950 is 1,280. So 1,280. 1,280. That's a 95th percentile score. Now, any question on this?
No.
Okay, any question for me?
No.
So, like I said, I don't know, some of you came later. Those of you that sent me the email for the makeup, I received your email. I'm getting the questions together that I will give the question that I will give you for the makeup. Hopefully by tomorrow night, I will start responding to you guys with your question. Okay?
Okay, thank you.
You're welcome. You guys have a nice weekend, and I will see you next week. Hopefully.
Nice weekend.
You too.
Did you get my attendance?
Oh, yeah. What's her name?
Kendra Pascasio.
Yeah, I got yeah, Keandra.
Okay. Thank
Yeah.
you.
Usually when they come in, and that's when I check it to the end.
Okay, thank you.
You're welcome. All right, guys, have a nice weekend.